Okay, picture the scenario. It's, say, 8:30 in the morning, you're in your kitchen, you're waiting for that first cup of coffee to brew.
The most important part of the day.
Absolutely. And you haven't even touched your laptop, haven't unlocked your phone. But while you're just staring at that coffee pot, your AI assistant has already rescheduled a meeting.
Okay.
It's drafted replies to 3 emails, and get this, it negotiated a delivery update with a vendor who was running late, all without you lifting a finger.
It sounds a little bit like a scene from a sci-fi movie, right?
Yeah.
Or maybe just the life of a CEO with a really, really good executive assistant.
Right.
But the thing is, this is actually where the technology is right now. We are standing on the edge of a fundamental change in how we interact with software.
And that is the hook for today's deep dive. We aren't just talking about chatbots anymore. We're not talking about, typing a prompt and getting a poem back.
No.
We're seeing this massive structural shift from generative AI to what people are calling agentic AI.
And the distinction is, it's so crucial. Generative AI, the stuff we've all been obsessing over for the last couple of years, it's fantastic at creating content.
Sure, it writes code, summarizes things, makes images.
Exactly. But agentic AI, it reasons, it plans, and most importantly, it acts. It has autonomy.
So if generative AI is the writer, agentic AI is like the employee who actually goes and executes the project.
That's a perfect way to frame it. Generative AI is a thinker. Agentic AI is a doer.
So our mission today is really to look under the hood. We want to unpack the tech stack that makes this leap possible. We're going to dig into deep learning, this concept called RAG, frameworks like LangChain, and the rise of multi-agent systems.
Basically, how did we get from ChatGPT writing haikus to an AI booking your flights and running parts of a business?
Exactly.
It's a fascinating evolution.
Yeah.
And to really get it, you have to go back to the brain of the operation. We need to talk about deep learning and, how these neural networks have changed to handle this level of complexity.
Okay, let's start there. The source material mentions that before we had these huge transformer models, the ones that power GPT-4, we relied on something called RNNs. What were they and why did we move on?
Right. RNN stands for Recurrent Neural Network. For a long time, it was the gold standard for handling sequential data, so anything like text or speech. The way an RNN worked was linear. It processed information one piece at a time in order.
Like reading a book one word at a time from start to finish.
Exactly like that. And that's fine for short sentences. But they had this massive structural flaw. It was called vanishing gradients.
Vanishing gradients. It sounds like a bad spy movie.
It does sound dramatic, yeah.
Yeah.
But in the math world, it was a total nightmare.
Yeah?
In simple terms, it just meant the network had a terrible short-term memory.
Oh, okay.
Imagine playing that game telephone, but by the time the message gets to the fifth person, they've completely forgotten who even started the chain.
Ah, I see. So if you fed an RNN a long paragraph, by the time it got to the end, it had no idea what the beginning was about.
It completely lost the context. It just couldn't handle those long-term dependencies.
Wow.
Which is, well, it's why the introduction of transformers was such a tectonic shift. That landmark paper from Google, attention is all you need.
I see that cited everywhere. Attention is all you need. So it introduced this attention mechanism. But what does that actually mean? How does a machine pay attention?
Okay, think about a sentence like, the cat wants to jump on the box because it is high. A human, we instinctively know it, probably refers to the fox.
Right.
An older model would just process that word by word, linearly.
Yeah.
A transformer, though, it uses this attention mechanism to look at the whole sentence at once.
So it's not reading left to right.
No. It assigns a weight or an importance to the relationship between all the words, no matter how far apart they are. It understands that cat, jump, and box are let's call them the gravitationally heavy words there.
Okay, the key concepts.
And it focuses on them simultaneously, so it maps the relationship between it and box instantly. It sees the whole picture, not just a stream of words.
Yeah. So that's the big leap, from sequential line-by-line processing to parallel processing.
Exactly. And that architecture, the whole encoder-decoder thing, is what powers the large language models, the LLMs that we see today. It gave the AI the ability to actually understand context on a massive scale.
And you can't be an agent if you forget what you're doing halfway through.
You can't. That context is the absolute prerequisite.
Okay, so we've got the brain. Transformers give us understanding, but we've all seen even the smartest models fail. I mean, confident hallucinations are still a huge, huge problem.
Oh, absolutely.
You ask a model about something that happened yesterday, and it just makes up a convincing but totally fake story because it's training data is 6 months old.
Right. The brain is essentially frozen in time. It's like a genius who's been locked in a library for the last year with zero internet access.
And that's where we need the memory, right? This technique called RAG.
Yes. Retrieval augmented generation.
I feel like RAG is a buzzword that gets thrown around constantly in tech circles,
Yeah.
but how does it actually work? What does it change?
Okay, think of a standard LLM as a genius student taking a test, but they're forced to do it entirely from memory,
Closed book exam.
a closed book exam. And if they don't know the specific fact, they might guess, right? Because they're trained to complete patterns to please the teacher. RI is like letting that student take an open book test.
I always did better on those. You don't have to memorize, you just have to know where to look.
That's it. That's exactly it. With R, when you ask a question, the AI doesn't just rely on its internal training. First, it uses a retriever to go search a trusted external database.
Like a company manual or a news feed.
Any trusted source. It pulls those facts into the conversation, and then, only then, does it generate an answer based on those retrieved facts.
The source had a great example with the Mars rovers.
Right. If you ask a base model, when was the last Mars rover launched?
Mm.
Without RAG, it might say, I don't know, or it might hallucinate a date.
Yeah, confuse it with an old one.
Exactly. With RAG, it first fetches the NASA database. It sees Perseverance launched July 30, 2020, and then it builds the correct sentence around that solid fact.
So it bridges that gap between just being a smooth talker and actually knowing things. But this is where the source material got really interesting for me. We're not just doing traditional RAG anymore. We're moving to something called agentic RAG. What's the difference?
This is a huge level up. Traditional RAG is a straight line. You ask, it retrieves, it answers, it's linear.
Simple enough.
Agentic RAG is a loop. It's iterative. The process is more like plan, retrieve, validate, and then generate.
Validate. So it can check its own work.
Yes. It can critique itself. Say the agent retrieves a document, but the document is blurry, or maybe it's the wrong version of a file. A traditional RAG system might just try to answer anyway, using bad data.
And give you garbage.
Right. An agentic system can realize, wait a second, this isn't what I needed. It can then go back, change its search strategy, and try again. It self-corrects.
That sounds infinitely more robust.
Yeah.
It's like the difference between a simple Google search and a research assistant who actually reads the articles for you.
It is, and we have hard data on this. The source mentions a really compelling case study from a German bank.
Oh, yeah. This was for their power of attorney workflows.
Right. And those documents are a mess. They're unstructured, legally dense. They vary by region.
Not something you want a chatbot guessing about.
Definitely not. But by using an agentic loop, the system could actually verify the data it was extracting. And the result was staggering. They reduced the process effort by 50%.
50. That's massive.
50%. And they saw a 30% drop in support tickets. And that drop is key, because the AI didn't have to give up and say, please contact a human every time it hit a small roadblock. It just solved the problem itself.
Okay, so we have the brain, which is deep learning. We have the memory, RAD, providing the facts. How do we actually build apps with this stuff? I can't just talk to a raw model and expect it to connect to my database. There has to be some connective tissue.
And that's where the skeleton comes in, the frameworks. And the 800-pound gorilla in this space right now is LangChain.
I see LangChain in every single developer newsletter. Is it a language, a platform? What is it?
Think of it as the glue, or maybe a better analogy is a general contractor. The LLM is the architect, right? It has the vision, the reasoning.
Sure.
But the architect doesn't lay the bricks or wire the electricity. LangChain is what connects the architect to the tools. It connects the LLM to your PDFs, your SQL databases, Google search, calculators. It creates chains, which are sequences of actions, and agents, which are the decision makers.
Can you walk us through an example of a chain in action? What does that actually look like?
Sure. Let's say you prompt an AI. Check Apple's stock price right now and calculate the 5-day average. A standard chatbot just can't do that.
Right. I apologize, but my knowledge cutoff is 2023. We've all seen it.
We've all seen it. But a LangChain agent looks at that request and it breaks it down. It has a kind of internal monologue. It says, okay, step 1, I need to call the Google search tool to get the current price. Step 2, I need to get the last 4 days of history. Step 3, I need to use the Python calculation tool to do the math.
So it's orchestrating those external tools to get you the final answer.
It's not just predicting the next word anymore. It's using tools like a human would. It knows it can't do math in its head, so it grabs a calculator.
And it turns the LLM into a kind of controller for other software.
Precisely.
Hmm.
And this whole ecosystem is getting more specialized. The sources also mention things like LangGraph, which is for more complex cyclical workflows where you need a human in the loop.
Like an approval process for a contract or something.
Exactly. Or you have Autogen from Microsoft, which is all about collaboration between multiple agents, and Crew AI, which is for orchestrating specialized agents with specific roles.
That leads us perfectly into the next layer of this stack, the workforce. Because up till now, we've mostly talked about a single AI bot doing everything. But the real shift seems to be toward these multi-agent systems.
This is a total paradigm shift. Instead of building one massive genius AI that knows everything from coding to tax law, you build a team of specialists.
Like in a company, you don't hire one person to be the CEO, the janitor, and the accountant.
Exactly that logic.
No.
The source described a setup using Autogen that was brilliant. It was like a little software development team. You have one agent as the coder, another as the tester, and a third as the reviewer.
And the magic is that they talk to each other, not to the human.
Yes, the human just says, build me a snake game in Python. The coder agent writes a script. The tester runs it, finds a bug, and sends an error message back to the coder.
Who then fixes it?
The coder fixes it. The reviewer checks for style. They just go back and forth, iterating, until the task is completely done. It's a digital office running at the speed of light.
And they don't take coffee breaks. But how do they talk? It's not just English, right?
They can, but they rely on specific protocols. The language of agents. The sources detail a few. There's A2A, agent-to-agent protocol. This is for direct negotiation.
Like my travel agent bot talking directly to a hotel booking bot.
Exactly. Instead of you searching Expedia, your bot asks the hotel bot, got a deluxe suite? The hotel bot says, no, just standard. And your bot says, okay, book it. It happens in milliseconds.
Wow.
Then you have MCP, the Model Context Protocol. This is about safely connecting AI to data. It's like a universal USB port for AI data, so connecting to a new database isn't a huge custom coding job every time.
And there was one more, AGUI.
AGUI, Agent User Interface. And this is all about how the agent explains itself to us.
Why is that so important?
Because trust is the bottleneck. If an agent books a flight for you, you need to know why it chose that one. AGUI lets it show its work. I booked this flight because it was the cheapest option under 5 hours as you specified. Without that transparency, nobody's going to trust an agent with their credit card.
That makes sense. Speaking of trust and capability, we have to talk about the model that was all over the source material, DeepSeek R1. It feels like this name just appeared out of nowhere.
DeepSeek is fascinating because it challenges the assumption that you need billions of dollars in a giant U.S. data center to train a state-of-the-art model.
They took a different approach.
A very different approach.
Right.
Instead of just massive supervised fine-tuning, which is just showing a model millions of examples, they relied heavily on reinforcement learning, RL.
Which is usually for games, right? Like AlphaGo learning to play Go.
Exactly. It's learning by trial and error. The model gets rewarded for correct reasoning chains. It was encouraged to think for longer, to explore different paths to an answer, not just mimic human text.
And the results were pretty good.
They were shocking. On certain math benchmarks, like Math 500, DeepSeek R1 scored a 97.3%.
97%, that's nearly perfect.
It surpassed OpenAI's O1 model on that benchmark. But the real kicker, and this is why the industry is kind of freaking out, was the efficiency. It was significantly cheaper to train.
That changes the economics of the whole industry. It democratizes the playing field.
Completely. It means a startup or a research lab outside of Silicon Valley can actually compete with Google if they're clever enough with their algorithms. It forces everyone to innovate on efficiency, not just on scale.
So let's bring this all down to earth. We've talked about the whole tech stack. What does this actually look like in the real world for us right now?
Well, it's changing fast. We're seeing a huge move toward multimodal AI. That means models that can process text, image, and audio all at once, natively, like GPT-4o or Gemini 1.5 Pro.
The example from the notes was great, uploading a picture of your open fridge.
Right. You snap a photo.
Yeah.
The AI doesn't just see pixels. It identifies the ingredients. That's vision. It understands what they are. That's the concept. And then it combines them into a recipe. That's the reasoning. You have eggs, spinach, and cream. You can make a quiche.
It's like the AI is finally stepping into the physical world. And on the consumer side, the source mentioned Amazon Alexa Plus. I mean, Alexa has felt stuck in 2014 for about a decade.
It's been a glorified kitchen timer, yeah. But Alexa Plus is their attempt to make this exact shift. It's moving from being rule-based,
Hmm.
where it only understands specific commands, to being generative and agentic.
So it remembers context now.
It remembers context, it can handle multi-step tasks, and crucially, it's proactive. The source mentioned that instead of you having to ask about traffic, it might just pipe up and say, hey, traffic is building on the bridge. You should leave 10 minutes early for your dinner reservation.
That's helpful, but also, I have to admit, slightly creepy. It knows where I'm going, and it's watching traffic without me asking.
And that is the ultimate trade-off of this agentic era, isn't it? Convenience versus privacy. To be truly helpful, the agent needs to know basically everything about your life, your calendar, your location, your emails.
Which brings us to the big wrap-up. We've covered a lot of ground.
We really have. This is a dense topic.
So to recap the journey, Transformers gave the AI the ability to understand context. Our Bridge gave it memory and accuracy to stop hallucinating.
LangChain gave it the structure to use tools, like a skeleton.
And now, multi-agent systems are giving it a workforce to act autonomously.
That's a perfect summary. And looking forward, the source hints at a shift toward SLM small language models. We might see a move away from one giant do-it-all brain to smaller, very efficient, privacy-focused models that run right on your phone.
Which would be faster, cheaper, and way safer since your data never has to leave your device.
Exactly. A swarm of small, specialized agents instead of one giant oracle in the cloud.
But before we go, there's a provocative thought left in the source material I want to leave our listeners with. It circles back to this idea of collective intelligence, where all these specific agents, medical, financial, coding, collaborate to make decisions for us.
Which raises a massive question of accountability.
Right. The question is, if an autonomous agent makes a bad decision in a multi-step chain, say, a financial agent makes a bad trade based on a coding agent's error, who is responsible? Is it the user, the developer, the agent itself?
We are moving toward a world where those lines of responsibility are going to get very, very blurry very quickly. When the software acts on its own, it's not just a tool anymore.
It's a proxy, something to think about while your AI assistant books your next vacation. Thanks for listening to The Deep Dive.
See you next time.